happens if we combine the trig and the inverse trig functions? Let's start with using the same ones, sine and arcsine. Well, arcsine of a half gives me the angle which has a sine value of a half. Well, from my 1, 2, root 3 triangle, that's pi on 6. And sine of pi on 6, from the same 1, 2, root 3 triangle, is the same value a half. Now this is true in general, for sine of arcsine and cos of arccos and tan of arctan. You get back the thing you put in. Now, of course, for sine and cos, you have to put in a value that could be a sine or a cos value between -1 and 1. Tan will work for all numbers. But this doesn't work in reverse. Consider sine of arcsine of x. Yes, if I put in pi on 6, sine of pi on 6 gives me the half, and then arcsine of a half gives me pi on 6. But if we think about, give me a moment to get a pen out, if we think about our unit circle, pi on 6 is here. There's another angle over here, which is 5 pi on 6, pi minus pi on 6, that has the same sine value of a half, the same y coordinate. So sine of 5 pi on 6 is equal to a half, and then arcsine of a half, by definition, gives me back pi on 6, the number between negative pi on 2 and pi on 2. Doesn't give me back this number. So arcsine of sine of 5 pi on 6 does not give me, necessarily, the number I started with, 5 pi on 6. Instead, it gives me back the reference angle between minus pi on 2 and pi on 2 that has the same sine value. And arccos of cos gives me back the reference angle between 0 and pi that has the same cos value. And arctan of tan gives me back the reference angle between minus pi on 2 and pi on 2 that has the same tan value.